Hello everybody. In this video we're going to answer the question together, what strategies can you use to compare fractions? So we've moved on from generating equivalent fractions using multiplication of the numerator and denominator and reducing fractions dividing the same number by the numerator and the denominator to get equivalent fractions, okay? But now what we're going to try to figure out which fraction might be the larger fraction and which fraction might be the smaller fraction. So in this case, everybody, when we compare fractions, we're going to be using the symbols that we've used earlier in the year just to compare whole numbers. We might use less than, greater than, or equal to. So you're going to see different fractions with different denominators, some with the same numerator, some with the same denominator. But as an example, these are really pretty simple to figure out. But I might have a fraction like 1/3 and a fraction like 1/5. Okay. Now in these two fractions you'll notice that the numerators are the same, okay, but the denominators are different. And in this case you are looking at the same whole, so you might be looking at a rectangle, okay, and the first rectangle, the 1/3, is divided into thirds and 1/3 of it shaded in. But if I drew the same rectangle and divided it into fifths, 2, 3, 4, 5, but shaded in 1/5, you'll notice that 1/3 is greater than 1/5. But I also might, let me erase this for you here. Whoop. I also might have a fraction like 1/8 and 4/8. Okay. Now you'll notice in this case that the numerators are now different, but the denominators are the same. So all we're doing simply is comparing the parts that are shaded in, since both fractions are divided into the same amount of equal parts. And in this case, only 1 out of the 8 parts are shaded in, and in this case, 4 out of the 8 parts are shaded in. So that means that 1/8 would be less than 4/8. For today's lesson, you're just going to have a model problem on your organizer and one practice problem for tonight. So I'm going to put the comparing fractions into some context through a word problem. And the problem says that 2 students sat down last night and started their web reading, just like what all of you are doing tonight as well. Sarah read for 3/4 of an hour. Todd reads for 5/6 of an hour. Who read for the longer amount of time? And you can use number lines to compare these two fractions and figure out who read for a longer amount of time. So in this case, what I might do is I have 2 number lines drawn, and they're going to be the same length. And I might say here, let's see, different color. I would say right here that this might be 0, or when they both started. And this right here would be 1 hour. Okay, since both of these numbers, 3/4 and 5/6, are less than a full hour. But I'm going to use some benchmark fractions, and the one that I'm going to use is 1/2. And I'll use 1/2 for both. Okay, so what my goal is I'm going to figure out which fractions might be less than 1/2, greater than 1/2, or equal to 1/2, or the same, or what one might be closer to 1/2 than the other. So I'm going to put both of these fractions on each number line, and that will give me a really good visual idea of which fraction is larger and which one is smaller. So I have 1/2 here, and since Sarah, I'll just use an S for Sarah, and I'll use a T for Todd, so I'll know that Todd will be at the bottom, that I know that I'll divide it, 3/4 is her time, so I'll divide this number line into 4 equal parts. And I know that 3/4 is right here. Okay? And now I'll look at Todd's, and it's 5/6. So I'll divide the bottom line into 6. Hold on one second here. I'll divide Todd's number line into 6 equal parts. So almost like each side of the half will be divided into thirds. And I'll now plot on the number line, or place in the number line, what Todd read. And I can know that that's, let's say I have 1/6, 2/6, 3/6, 4/6, and 5/6. So I know that Todd read 5/6, and just visually I can see that Todd read for the longer amount of time. So who read? Todd read So in this practice problem, I'd like you to use two number lines, okay, just like I did in the model problem, and label the number lines with 0, 1 hour, and use a benchmark fraction like a half, okay, and figure out which fraction might be larger, smaller, or equal to 1/2, and label each amount of time, okay, on the number line, and that will give you a good visual representation of who read for the longer amount of time. So again, in this video, what we started to do was answer the question, what strategies can you use to compare fractions using number lines and benchmark numbers?